Okay, good morning. Hope everybody had a good weekend and staying safe. Had a good 3 day President's Day, Valentine's Day weekend. So let's. Okay, so these three assignments are what we've had done so far. So example 2.2, 2.4, and 2.5. So those were due Monday, I think, or up to Monday. And so I'll get those graded soon, and I'll start posting your grades for the assignments. We're a few days behind because of the holiday and because I wanted to take an extra day on that example 2.5. And so we're going to do the curve fitting a little bit later because it's not as relevant to the first midterm. And I want to make sure I get all the exercises that go on the first midterm done first. And so we're most likely going to skip this till after the first midterm and come back to it in a couple weeks. But we'll still do it because it's a kind of a fun assignment. So let's jump so on the syllabus. Okay, we've done these three. All right, we're going to skip this one for now. We're going to come back to it. We're still going to do it, but today I'd like to do example 2.6, and then that'll be due next Monday. But we haven't got to this one yet because again we're a couple days behind because of the holiday. So these three are already due. I'll get those graded soon, and then this one we'll do today, example 2.6, and that'll be due Monday. Okay, and we'll probably get to the rest of these four before the first take-home midterm, and then I think we'll do this one after the midterm because I have a couple extra days there. Okay, so today, example 2.6, yeah. All right, so if you go to example 2.6, you'll see that there's our normal stuff. You can open up the calculating NPV Excel file. Okay, you can open up the example 2.6 Word document. Okay, and I think we'll have time to get to the practice problems later, so I'll open that up when we finish these two things. So let's see. All right, there's an optional video there on doing some net present value and internal rate of return, which I'll explain both those things in Excel. We'll do those things today, but if you want to check out the video, it's got some more information on how to do these concepts in Excel. So look at that if you get a chance. Today's concept, I guess, is net present value. And so you might have learned this concept in a previous business class or finance class or just come across it. But it's a pretty useful concept, and we'll do a little exercise on it. So let's first talk about just what the time value of money is. And so what we're going to have here, and what we have typical in many business situations, is that you get money now, and you also get money during a stream of future payments. So in many business situations, cash flows are received at different points in time, and a company must determine a course of action that maximizes the value of the flows. So not only are we worried about what revenue comes in now, we're worried about what revenue comes in future periods and how much we value that. Okay. So what we're going to do is to make decisions when cash flows are received at different points in times, which is going to be the case. All right. The concept here is that the later a dollar received, that the less valuable the dollar is. So that means that if you're going to wait to receive money, you have to get paid more because that money's worth less. You could have used it now. You could have used it to to invest. You could have used it to put it into an account that earned interest. And so the longer you wait, the more you have to get compensated for it for waiting. Okay? So that's the idea here. And we'll see that payments received in the future are worth less because we had to wait longer to get them. All right, and some of the key terms we're going to learn: discount factor. So let me just show you, if you scroll on this little page, and you'll see on the second page there's some practice questions, and this has the nice formula of present value. All right, and so the discount factor is how much you discount a future value. So 1 plus I raised to the n, I guess 1 divided by 1 plus I raised to the n is the discount factor. And that's how much you discount a future payment, and that'll make total sense when we do these exercises. Okay, present value is just the present value of what the stream of payments is today. So see, if you're getting a bunch of future payments in this format, then the present value is how much those future payments are worth after you discount them. Net present value, which is the thing we're doing today, is basically the present value minus the cost to do the business or the investment. So it's just the present value minus the initial investment or capital cost. And then the discount rate is just the interest rate, which is this little I. I is the discount rate. So we're going to learn all about this equation here for present value. And we're going to do a little business exercise in Excel, and then we'll do some practice problems. And yeah, there'll definitely be one or two of these on the take-home midterm. Okay. All right, let me see if I can find a little description of this exercise, and we'll start doing it. So this is example 26 in your textbook, which is calculating NPV at Akron. And again, we're using the calculating NPV Excel file. That one there. Okay, so here's what we're doing. So example 26, Akron is a large drug company, at the current time, the beginning of year 0. Akron is trying to decide whether or not one of its new drugs, Niagara, is worth pursuing. Niagara is in the final stages of development and will be ready to enter the market in year 1. The final cost of development to be incurred at the beginning of year 1 is $9.3 million. So Akron estimates that demand for Niagara will gradually grow and then decline over its useful life of 20 years. So this drug is going to be profitable for 20 years. After that, it's either not effective, or probably after 20 years, a lot of times what happens for pharmaceuticals is the patent wears out, and like all the, then Amazon starts making it or something. Okay, specifically, the company expects its gross margin, revenue minus cost, to be $1.2 million in year 1, and then increase at 10% through year 8, and decrease at an annual rate of 5% through year 20. So it's going to increase in revenue for 8 years, and then decrease for the remainder of the 12 years. Okay, so we're going to develop a spreadsheet model of the 20-year cash flows, assuming its cash flows other than the initial development costs are incurred at the ends of the respective periods. So that's important because that tells you how to specify your discount rate. Okay, if you have to wait a year, you have to discount it. If you get it now, you don't discount it. So using an annual discount rate of 12%, Okay, so this is an example, but that would be a very high interest rate because currently good interest rates are something like 3.5%. So, but we'll use this 12%. We'll calculate NPV, and we'll see what the drug company can do with these questions. So number one, is the drug worth pursuing? Is the investment worth the cost, or should it not incur the 9 million and just abandon this project? Okay, and then we'll do some sensitivity analysis and change some things and see how the answer to this question depends on the interest rate and some other factors. Okay, so if you look at the spreadsheet, there's not a whole lot to it, but this is all we need to do the analysis. All right, so the development cost is 9.3 million. The gross margin in year one is 1.2 million. That's going to increase the gross margin for 8 years at 10% annually. And then after year 8, so 9 through 20, the rate of return is going to start decreasing at 5% annually, and the discount rate is 12%. Okay, so you can think of the discount rate as if we didn't take this investment, we could earn 12% return in some other bank or interest-bearing account, and so that's kind of the benchmark. And so this project or this drug has to give us a return of more than 12%. Otherwise, we're just going to put our money in some bank account or buy some investment that pays us 12% and it is safer. All right, so we'll have all our gross margins each year, and we'll calculate the NPV, and then we'll do some tables. Okay. All right, so step one is let's highlight our inputs, decision variables, and objectives. We don't have, or do we have a decision variable? I don't think we do. So I think we only have inputs and objective here. So there's technically no decision variable. We're just trying to see if this investment is worth it. Okay, so we have an objective and we have inputs. Let's go ahead and set those up. Okay, well, it says here these are inputs. So development cost through rate of return. These are the inputs. So you can highlight B4 to B9 in our input color, which is light blue. All right, and we have an objective, which is right there, B33. All right, so you can highlight, actually, yeah, that's right. Okay, so B33 is going to be the NPV. So you can highlight B33, that's our objective. We're trying to get that as high as possible. We're trying to see what that is. So B33, objective color, which is highlight yellow. All right, so step two is remember we're gonna create some range names so we can refer to them later, and hopefully there were some issues with range names before, so hopefully we got the range name situation solved, and we can do those the same way. So let's create some range names for step two. Okay, so we're going to go ahead and make a range name for this whole block of inputs because it's right here. So let's go ahead and we can do this, hopefully we can do this in one step. All right, so if you want to go ahead and select A4 to B9, all right, see that whole area? We can make a range name for those 6 inputs together at the same time. To do that, Formulas tab, create from selection, and then left column should be the default, which is going to give, this is going to be called development cost. This will be called gross margin year 1. So it'll name all these according to the description in the left column, so you can just hit OK. All right, and then again, to check that what you just did, Formulas tab, Name Manager should show you the 6 range name cells you just made. All right, so we haven't done range names for like a week, because we had a different exercise and we had a day off. So everybody good on making range names? There were some issues with that before, but I think we should be good on that. Okay. Okay, let's make a few more range names. All right, so we need to make a range name for this whole gross margin area, which is going to cover the 20 years. So if you want to select B12, B12 to B32, all right, so this whole area, it's going to be called gross margin. So select B12 to B32, and then Formulas tab, create from selection, top row. So this whole range name will be called gross margin. Okay. And then this is supposed to be moved down one. So because it'll to sync up with the formulas I wrote in the steps in the textbook. So if you just want to click on the row 32, actually, sorry, row 33, and under Home tab, hit the Insert button, and let's just move that down to row 34. See that? So there's a space here, and the NPV is here, and the objective here is in V34. All right, let's double check our range names. Formulas tab, Name Manager. So we got development cost, we got discount rate, we got gross margin, we got gross margin year 1, we got peak year, and we have rate of decrease and rate of increase. So those range names we should have for this exercise. So just the inputs and then that whole range for the gross margin. All right, so we're good on range names. Step 3 is to estimate the cash flow. So we're going to give the first value, just the initial value, because we don't have to discount it. And then the rest of the years, we have to set up the whether it's increasing or decreasing based on the year. All right, so let's put this in the first year, and then this big formula in cell B14. And I'll explain that formula, and then we'll copy it down to apply to the rest of the years. So let's go ahead and estimate the cash flows here. All right. cell B13, which is right here, type in that initial formula, which is just going to refer to the range name, equals gross margin year one. Okay, so you should have made a range name for that, and that's just saying that at the end of year one, we get 1.2 million, and we don't have to discount it because we get it right away. Okay, but the rest of them are either increasing or decreasing based on the year. So we're going to start increasing, and then we're going to start decreasing. So you can put in the big formula that you see in step 3 in cell B14. So right here, for year 2, it's equals okay, so here's our formula. It's equals if function, and then in the parentheses, A14 is less than or equal to peak year, comma, B13 times parentheses, 1 plus rate of increase, close the parentheses, comma, B13 times parentheses, 1 minus rate of decrease, and then 2 parentheses there. So make sure you get the signs right. This is the most common error here, is this is a plus sign, 1 plus rate of increase, and this is a minus sign, 1 minus rate of decrease. All right, and so what this does, this formula, it's nice because it tells you exactly where you are. So it says if the year is less than or equal to the peak year, which is 8, all right, so if we're in a year that's less than 8, we're going to increase the previous year by 10%, all right, 1 plus 10%. Otherwise, if we're past the peak year, we're going to decrease at 5%, so 1 minus 5%. Okay, so if you set that formula up, it'll tell you, it'll do exactly what you want. It'll increase for 8 years, and then after year 8, it'll decrease for the rest of the time. Okay, so we should get 1.32 there.
Wait, I got a different number.
Okay, what number did you get?
I got 1.14.
Is this one 1.12 or 1.2?
It's 1.14.
The first one or this one?
The second one.
The second one, but this one is 1.2.
Yeah.
Okay, so it probably just a little error in your formula. So let's just double check the commas and the sign. So it's equals if A14 less than or equal to peak year, comma, B13 times parentheses, 1 plus rate of increase, and then close the parentheses, comma, B13 times parentheses, 1 minus rate of decrease, and then double parentheses. So just, if the formula is that, I think it, unless you didn't do unless the range names aren't referring, but in that case, it wouldn't calculate. So do you have the formula just like this?
Yeah.
And it's not giving you 1.32?
Nope.
Okay, well, I can take a look at it and fix it. So if you want to.
Okay.
why don't you, under Example26, just post it, then, and as soon as you post it, let me know and I'll take a look at it.
Okay, thank you.
All right, so we'll do one more. We'll apply this to the rest of the years, and I'll take a look at that one. So all we have to do is, if you got the right formula and you got 1.32 here, we're going to apply this formula to the rest of the year. So just click on B14 and grab the bottom right corner and drag it down like this. Okay, and that should give you the gross margin for each year. And you can see that this, I don't know what's going on with the decimals. We're gonna format this so we can see if we got the same thing. So you can, if you got that, you can select the whole region, which is B13. And let's go all the way down to B34 because this is going to be the same formatting. All right, so B13 to B34, and let's change that format. Home tab, format, format cells, currency, 2 decimals with the $sign. Okay. Okay, so that looks a lot nicer, and you can check your values there. And these are in millions, right? So this is like 1.2 million, all the way down to 1.6 million. All right.
What happens if you're having issues dragging down and it's not putting in the equation?
When you try to drag it down, it didn't work.
It's just repeating the numbers.
Oh, there's probably well, you could try hitting the F9 button, and if that doesn't work, you can try formulas. Hit the calculate now button. If that doesn't work, then there's probably something wrong with the formula.
I'm sorry, so you went to format cells and then selected currency?
Yes, so I'll do that. I'll do that step one more time. So the person who was getting the same numbers, did that fix your problem?
No, still working on it.
Okay. All right. So let me do this step one more time, and then I'll try to fix these two. So yeah, I selected the whole range with all the millions of dollars. So B13 to B34, and then home tab, format, format cells, and then you can choose the category to currency, and you can choose 2 decimals and the $sign symbol and hit OK, and that should do it. Yeah,
Thank you.
you're welcome. Okay, let me see if. I think I see. Your problem is, Raymond, this should be A14.
Oh, okay.
I think that's it. Let me see if A14. Yeah, I tried. Just change that first. Instead of A1, it should be A14. I think that should be it.
Oh, okay. Okay, thank you.
Yep.
Could you check mine real quick, Professor?
Yeah. Did you post it?
Yes.
Okay. Gotcha. Okay, so your problem was when you dragged it down, it gave you the same thing. So let me see. Well, it looked like it worked on mine. It looks like the formula's right, and I dragged it down, and it looks like it worked. Yeah, it looks right to me. It doesn't work for you?
No, it's not. It's still dragging down the 1.32 just all the way down.
Well, so you have this part, and then you can't just grab this and drag it down?
No,
What, what is it? So when you try to do this, what happens?
it's the 1.3 repeat.
Oh, okay. So I think if you try this, formulas, and then hit this calculate now button, try that.
Calculate what?
Okay, so formulas,
Yeah.
and then you see calculate now up here?
Calculate now. Okay. Yeah, I'll try that.
Okay. Well, yeah. See if did that work?
No, it's not.
That doesn't work?
No, it's not.
Okay. Well, the other shortcut, I mean, because I have the same formula you put in, and I just applied it down, and it's it's working correctly.
All right, I'll just catch up and find out what I'm doing wrong.
Okay. Because again, you're not doing anything wrong. You have the formula right, and all you got to do is apply it down. So, or you can try this. You can try copy and pasting it. So just Control C, copy, and then select this region. Control V. All right. Try copy and pasting it. See if that works.
It's working. Thank you.
Oh, yep. All right. Yeah. So that the dragging down. I'm gonna turn your sound off. Okay. Yeah. So the dragging down shortcut is it's just a shortcut for copying and pasting. And so there's always workarounds, but yeah, that doing that apply down when you grab the bottom right corner, we're just shortcutting a copy paste. Okay, so you can always do that. All right, so we're good with the MPVs. I mean the gross margins, yeah. And the next step is to calculate the MPV. Oops. All right, so we've done step 3, cash flows. Step 4 is to calculate the NPV in the objective cell B34. All right, so let's put this big formula in B34. Okay, equals. Okay, equals negative. So see how there's an equal sign, and then right after the equal sign, I have a negative sign. So don't forget that negative sign because we have to pay or subtract the development cost. So equals negative development cost plus NPV formula, and then in parentheses discount rate, comma gross margin. Okay, so we're using the NPV formula with our range names. So what this is going to do is take out the development cost of 9.3 million, right? All right, and then add the net present value of all these cash flows with discount rate 12%. So this is a big shortcut, or this is a big calculation of NPV. All right, so we subtracted the development cost, we got the gross margin, and we used this discount rate to discount all the gross margins with this discount rate. So with that said, the NPV, or the present value of all these discounted gross margins minus the development cost is, or should be, 3.30 million. Okay, did we get that? All right, so the question is the drug worth pursuing, or should Akron abandon it now and not incur the 9.3 million development costs? So this is our net present value. Okay, and so the question here is, should we pursue the drug? All right, so should we, if our NPV is 3.30 million, should we pursue the drug? That's the question. Okay, so I mean the answer is yes, we should, because the net present value is an estimate of all the discounted payments or cash flows minus the development cost. So this is saying that after we took out the development cost, the net return is an estimated 3.30 million. So that should be a better return than we can get at just 12% of the market. So yes, if your NPV is essentially positive, that means you outperformed the development cost, and you should go ahead and do the investment. Okay, so positive NPV means it's worth at least more. It doesn't mean there aren't other options, but it means that given the discount rate and the initial development cost, that it's worth it. Then it's better to do this than to not do it. Okay, let's do a couple data tables. So let's see how NPV changes to years of sales. So we're going to show how, or I guess the peak here. So we're going to create a one-way data table like figure 2.40, and we're going to show how NPV changes when the peak year changes. Okay. So what we're going to do is, the peak year is 8 now. So when the peak year, when the thing, when the drug increase, the peak year changes up or down, how does that affect our decision? Okay. All right. So the table, we're going to make it in D11. So we got some space here. And let's go ahead and start in D11. Let's give it a title. And let's call this sensitivity of NPV to peak year. Okay, sensitivity of NPV to peak year. So that's exactly what we're looking at, is how the NPV changes when this changes. And if you want, you can make that title bold. Just the shortcut is Control B, or you can hit this under Home tab. There's a bold button. There we go. Okay, and right here, we're going to link in the MPV. So in cell E12 equals B34, or yeah, so we don't have a shortcut for that, so equals B34. Okay, so in E12, the formula is equals B34, and we're going to list some possible peak years. 3 through 10, okay, so in D13, D3, we're going to have to format this, 4. And then we can go ahead and just count up to 10, or you can type it in. So if you select the 3 and the 4, you can use Excel's shortcut to drag the bottom right corner and count up to 10. 3, 4. Okay. And then, I don't know why there's so many decimals. So if you want to, on the Home tab, see the shortcut here, decrease decimal, hit that until they're all just whole numbers. Okay. All right, so here's what you got in this range. D13 to D20, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Okay, so everybody good on this so far? All right, we're going to make a data table by selecting D12 to E20, all right? This whole area, D12 to E20, data, what if analysis, data table, okay? And we don't have a row input cell because we're only changing the column, and the column input cell should refer to peak year, which is B6. Okay, this is blank, this is B6, and hit OK. All right, and aside from formatting, we should get these values. And if you want to go ahead and select E13 to E20, and let's format that to look like this. Home tab, format, format cells, currency, decimals 2, and the symbol is $. Okay.
Wait, how'd you get those values again?
Sure. So okay, we're gonna make our data table. So you got this right here is equals B34, and you got 3 through 10 here. So if you got that, you can select the area. D12 to E20, and then data tab, what if analysis, data table. Okay, it's a one-way. We're only changing the column, so this is blank. Column input cell should refer to your variable peak year, which is cell B6. Okay, so blank B6. Okay, and that should do it. All right, did that work?
Yeah.
Okay.
Yeah, thank you.
Then we're just gonna format these to look like normal numbers. So E13 to E20, and I just did Home tab, format cells, currency, 2 decimals, symbol $, and okay. Okay, so if we got that, the last thing we'll do for this step is to there's only one of them, but you can highlight the values that are negative. So that would tell you that if it only increases less than or equal to this number of years, don't do it. All right, so let's select E13 to E20 again, and then Home tab, Conditional Formatting, highlight cell rules, less than, and you want the values that are not worth it, so just put 0. Format cells that are less than 0, and then hit OK. And that should give you the only situation which is negative, which is 3. And so essentially that means that if this project or this drug only increases for 3 years or less, it's not worth it. But given the current parameters, if it increases for 4 years or more, then it gives you a positive return. Okay. So do we get that here, the data table for peak year and the formatting? All right, so step 6, because we like data tables so much, we're going to make one more. And in this time, we're going to show a two-way table and see how NPV changes to both peak year and rate of increase. So we're going to look at two variables that affect NPV and make a bigger table, a two-way table. Okay, so let's do that. Okay, we'll start this table, or we'll put the title in D22, so you can go down there, and let's type in a name for this table. And let's call this sensitivity to peak year. And rate of increase. Okay, sensitivity to peak year and rate of increase. You can hit the bold shortcut if you want under Home tab. And we're going to set this up to show how NPV changes with different peak years and different rates of increase. So in D23, this is equals B34. Okay, that's our NPV. So in D23, just your formula is equals B34. Let's put different rates of increase across the top, and we might have to format this, but we want 5% to 10% in increments of 1. So this is 0.05. This is 0.04. I mean, sorry, 0.06. All right, and we want to count up to 0.1 in the 0.01 increments. So if you want to shortcut, select E23 and F23, and grab the bottom right corner and just count across up to 0.1. Okay, there we go. And let's go ahead and make this, I'd like to see these in percents. So if you got that here, 0.5, 0.05, 0.06, 0.07, 0.08, 0.09, and 0.1. That's just the decimal form of the percents. But if you select the region and under Home tab, actually, let's see this. There should be a shortcut under Home tab just right here. there's a little percent sign. Just hit that button if you have it. It'll change it to percent display. So you get 5 through 10%. And then let's list some possible peak years down here. And we want 3 through 10. So I think let's just copy and paste this. Okay, so if you want to select D13 to D20 and copy that, Control C. Okay, go down to D24 and paste it, Control V. There we go. So we got our table set up here. All right, and then we're going to make the table. So if you want to select D23 to J31, then data tab, what if analysis, data table. Okay, the row input cell is now going to be rate of increase, which is B7. The column input cell is the same as before, which is peak year, which is B6. Okay, row input cell is B7, column input cell is B6. And let's hit OK. Yeah, and we should have got different corresponding MPVs given the two changing rate of increases and peak years.
Wait, could you do that one more time, please?
Sure. Okay, so you got this part set up, right? And then we just need to do the table. So make sure this is equals B34. You got 5% to 10% here, and you got 3 to 10 here. All right, so then to do the data table, you got to select it all. D23 to J31. Data tab. What if analysis, data table, and our row input cell, right, is B7. Column input cell is B6. Okay, that is rate of increase, and that is peak year. So B7 there, B6 here, hit OK, and that should do it. Yeah, did that work?
Yeah, thanks.
All right. Okay, a few more things. Let's format this, do some conditional formatting, then we can see what this tells us. All right, if you go ahead and select all the inside, E24 to J31, and I want to just format it to currency and then do conditional formatting to show the negative situations. So first, Home tab, format cells, currency, decimal places 2 and symbol $sign. Okay, and then while you got this selected, E24 to J31, Home tab, conditional formatting, highlight cells rules, and less than, just change that to 0, and hit OK. And that should give you the situations or scenarios in which if these two situations occur, then the development cost is too high. So for example, if it's, if the peak year is 3, then nothing's good. If the peak year is 4, then you got to have a rate of increase of at least 10%. And if the peak year is 5, you got to have an increase of at least 7%. Any increases from peak year 6 to 10 are all good. So see, this will tell you if you get some changes in your rate of increase or your peak year change to one of these scenarios, then it becomes not worth it to do this investment. Okay. Did we get everything here in the table? Yeah, okay. Next step, we're almost done with this, with the Excel part at least.
I'm sorry.
Oh,
I
sure.
just I'm having trouble when I selected what if analysis and I'm creating the data table. All the numbers are wrong, but I have all the formulas right.
So are the numbers different, or are they all the same, or are they wrong?
Yeah, they're all different. I'm gonna turn it in so you could take a look at it, please.
Yeah, post it to the discussion and I'll look at it in a second. Okay. All right, so let's do one more step and then I'll look at that. So we've done this. So the last step for the Excel portion is to calculate the internal rate of return. And this is a nice concept because this shows the discount rate at which we break even. So given all the other parameters, what's the interest rate at which the net present value is 0? So that would tell you exactly, if nothing else changes, if your discount rate is at least this, it's worth it. If it's less than that, it's not worth it. So to calculate that, let's use Excel's goal seek feature. Okay, so I think we all have this option, data and what if analysis and goal seek. Do we see that? Okay, so if you got that data tab, what if analysis, then goal seek, and we're going to specify our problem to give us the internal rate of return. So let's set cell. Okay, hit this button and choose this one, B34, to 0 by changing the discount rate, B9. Okay, so if you got here the goal seek, the parameters are set cell $B, $34 to 0 by changing $B, $9. Then let's hit OK and see if that works. And if we got this far, it should give you a solution. It says we found a solution for you. Hit OK. And that solution is about 17%. And you can see that that's exactly the discount rate, which gives us an NPV of 0. So that's the internal rate of return. So we kind of break even. So if it set that for us, or it should have, and that gave us an NPV of 0. So that tells us that if the discount rate is 17% or more, it's not worth it. And if it's 17% or less, it is worth it. And you can verify that by, let's change this to 18. First of all, did we get that part, the internal rate of return goal seek thing? Okay, and then let me just explain what that. So this means that if the discount rate is bigger or less than, that's going to change our NPV. So watch, if I change it to 18%, that's going to make the NPV negative, or it should. See? And if I change it to 16%, it's going to be positive. See? So that's a very important internal rate of return thing, because that tells you right, if the interest rate is too high, if it's above 17%, then the discounted returns are not worth it. You should just put your money in some interest account and earn 17%. But if it's less than 17, it's worth the development cost. Okay, so you can leave it. I'm going to put it back to the original, which was 12%. All right, so here we go. Andrea, your problem was this. Oh, so they're all this. I see what happened. Oh, I think. Well, I know the problem is this. This should refer. This should say equals B34, and that's it. So because you just, I think the number was just typed in instead of referring to the NPV calculation. So Andrea, if you just change D23, type in equals B34, that I think that'll do it. So
Got it. I was having trouble with it because I wasn't putting the equal sign before it. I'm sorry. Thank
no,
you.
that's it. Yeah, and then just format it, and then I think you got it. Okay, so I think we're done with this, the calculating NPV spreadsheet. Everyone good on this? All right, so let's do a few practice problems, but the spreadsheet portion or the assignment is done. And so if you got that calculating NPV spreadsheet done, or whenever you do, you can post it right here, Example26. So this is due next Monday. So there's only one assignment due next Monday. This one, Example26, because we didn't have class on Monday. So this one goes here whenever you're done with that. Let's look at a few practice problems that relate to present value. So, nope, that's not it. Example26. Example26 practice question solved. Okay, so number one, here's practice question one, and so there might be one of these similar on the practice take-home mid or the actual take-home midterm. So here you got your present value formula. We can use that to answer some questions. So the formula we given, or I mean, it's a take-home work. So there it is. So part A. Let's suppose that the interest rate is 4%. And the question is, what's the future value of $100 4 years from now? Okay, so this will show you that to use this as future value, just multiply both sides by 1 plus I raised to the n, and that should give you that the future value is equal to the present value times 1 plus I to the n, right? So this will show you exactly how you get future value. You just, it increases at 4% per year, depending on the number of years. So future value is equal to present value times 1 plus the interest rate raised to the number of periods that you get interest, okay? So let's put in our values. The present value is 100. The interest rate is 4%, so remember in decimal terms that's 0.04. And 4 years from now, so that means the n, the number of years, is 4. Okay, so that just means that $100 earning 4% for 4 years is about $117. Okay, and then part B, how much of the future value is total interest? So you started with 100. You earned $117 in 4 years, so that means that you earned $17 in interest. So 117 minus 100, you got $17 of your future value is total interest. Okay. Part C, by how much would total interest be greater at 6% than at 4%? So you know that you're going to get a higher return at 6%. Let's find that first. So first, just start with the future value. is equal to the present value times 1 plus I raised to n. So you have to increase it 6% for 4 years now. Present value is still 100. Now the interest rate is 6%, so that's 0.06, and we're still going to do it for 4 years. Okay, so $100, increasing at 6% for 4 years is about $126. But the question was, by how much would total interest be greater at 6 than at 4%? So here we earn $26 in interest. So at 4%, we got 17. At 6%, we got 26. So the extra interest is $9, 26 minus 17. So total interest will be greater by $9 at 6%. All right, so this is a small example, but a little change or a little increase in interest can really increase your total future rate of return. Okay, so questions on that one? All right, so let's do one more. So again, you don't have to turn in the practice questions, but make sure that all the concepts and you know how to do it, because I'm trying to just give you some example and some practice for the coming take-home exams. So practice question number 2. This time we're going to basically do a manual calculation of NPV, like we did in the Excel sheet, but it's simplified because we don't want to do 20 years of calculations. So here's the question. Darth Vader Jr. is contemplating the purchase of a new Death Star that will cost $1 million. It has a useful life of 3 years. The Death Star will yield year-end revenues of these $500,000 in year 1. Okay. Then $500,000 in year 2, and then $500,000 in year 3. Then after year 3, it doesn't have any return. Okay, so the question is, what is the net present value of the Death Star if the interest rate is 25%? So all you have to do is sum up the stream of present values, discount them, and then subtract the initial development cost of $1 million. Okay, so let's take this for year 1. So in year 1, we get $500,000 divided by 1 plus 0.25%. So 25% is 0.25%. So we get 1.25, and it's year 1. So this is the discount. This is what we divide the discount factor for year 1. Okay. For year 2, we get 500,000, and we discount that by 1 plus I, 1.25, and now it's raised to 2 because you got to wait 2 years. Then the third one, year 3, you get 500,000. Divide that by 1.25, and now it's raised to 3 because you got to wait 3 years. All right, so each of these future values is worth less because you could have otherwise put that revenue into an account and earned 2.5 or 25%. So the longer we wait, the less these values are worth. So this one's worth a little bit less than the previous, and this one's worth a little bit less even so. So this is the sum or the discounted revenues for the 3 years. So year 1, year 2, and year 3, and then the project or the Death Star costs $1 million. So we have to subtract that and see if it's worth it. So the discounted revenues minus the initial cost is negative 24,000. Okay, and so make sure you can set this part up and show your work when you do this for an exam, and just put this stuff in your calculator. You should get I try to make it come out even, so this one's negative 24,000. B, should Darth Vader Jr. purchase the Death Star? And he should not, because the MPV is 0. And so unlike the Akron drug we just did, which had an MPV of like 3.3 million or something, this MPV is negative, which means that the initial costs more than what we got in return for the discounted 3 years. Yeah, so questions on what we did here for this one? All right, well, I think we'll finish a little bit early today because that's why I wanted to cover today. We did example 2.6. So example 2.6, calculate MPV file goes here when you're done with that. All right, some of you have already turned it in, so that's due by next Monday. And so don't worry about this one because we haven't got to it yet, and we didn't do this one yet. So these 3 were already due. I'll get those graded soon, and this one is due Monday, which we just did, and then that's all we've done so far. Okay? So this is due Monday, and I think if there's no more questions, I think that might be it for today. And so thank you all for joining. Everyone stay safe and have a good weekend, and I'll see you Monday morning.
Thank you.
Thank you.
Thank you, Professor.
All right, thank you.
Professor?
Yes.
Sorry, I created a thread again because I had corrected my mistake, and for some reason I accidentally selected the wrong file. It was the one where the mistake was, and I don't know how to delete it. Do I just create a new one, and like what should I make the title so you can know that's the new one?
Oh yeah, for some reason I don't think you can delete it. So, did you?
I have 2 there, yeah.
It doesn't. Oh, just whichever one is. Yeah, the students post. I mean, whichever one is newest is the one I'll look at for final grading. So don't worry about it as long as you have it. So like if I sort.
Got it. Okay, I'll just say final version or something.
Yeah. So is this the right one, the correct version?
Oh no, that I accidentally selected the wrong file for that one
Yeah.
too.
So yeah, don't worry about it. Just post a new one, and then whichever one for Andrea is. See, I'll see which one is the newest, like by time. I'll
Okay.
just say like this is the. Yeah, I'll just look at the one you say that this is the right one.
Okay, thank you so much. I apologize for that.
No, that's okay.
Okay.
Okay.